Welcome to Your Math Explained, where we make math simple and clear. My name is Angela, and in this video, we're diving deeper into logarithms, not just using the log laws, but actually proving them. So proofs are quite daunting for a lot of students. But don't worry, we're going to go through this step by step, and by the end of the video, you're going to be a pro. So first, we're going to prove the product rule. Recall that the product rule says log base c of a plus log base c of b is equal to log base c of a times b. So what we're going to do is we're going to let x be equal to log base c of a, and then we're going to let y be equal to log base c of b, and we're going to let z be equal to log base c of a times b. And then a lot of the times what you want to do is you want to write down what it is that you're trying to show. So we shorthand that by writing WTS, which stands for want to show. And here, what we want to end up with is we want to show that x plus y is equal to z. So this is a good thing to write down because you know what your endpoint is. And also, because this is what we want to show, you want to make sure that you're not using it within your proof as a step. Okay, so now that we have that on the side, let's go ahead and use the definition of logarithm to rewrite each of those three equations. So the first one is going to be c to the power of x is equal to a. The second one is going to be c to the power of y is equal to b. And then the last one is going to be c to the power of z is equal to a times b. So now notice how for the last one we have a times b. And then our first equation has an a and our second equation has a b. So what happens if we multiply them together? Well, if we were to multiply our first and second equations together, the left-hand side is going to be c to the power of x times c to the power of y. And that is going to be equal to a times b. But from the third equation, we know that a times b is equal to c to the power of z. And now we can use our exponent laws to combine c to the power of x times c to the power of y. We know that is going to be c to the power of x plus y. And that is equal to c to the power of z. So now our left-hand side and our right-hand side, they're both exponential expressions with the base c. So since they're equal to each other, that tells us we just have to compare the exponents. So we end up with x plus y is equal to z. And now we can stop because this is exactly what we wanted to show. Now we're not going to be proving the quotient rule because it's basically identical. What we're going to do is now we're going to go ahead and prove the power rule, and we're going to be doing something very similar. So we're going to start with by letting x be equal to log base a of b. And then we're going to let z be equal to log base a of b to the power of n. And just like the previous question, we're going to write down what we want to show. So we want to show that z is equal to n times x. So we're going to box that. Okay, and just like what we did last question, we're going to use the definition of log to rewrite these two equations so that they are exponential equations. So then the first one, we're going to get a to the power of x is equal to b. And then our second equation, we're going to get a to the power of z is equal to b to the power of n. So now looking at these two equations, if we take the first equation and raised it to the power of n on both sides, then on the right-hand side, we're going to get b to the power of n. So let's go ahead and do that. So we're going to take the left-hand side raise it to the power of n. And then we're also going to take the right-hand side and also raise it to the power of n. But now we know that b to the power of n is just equal to a to the power of z from the second equation. And now we can use our exponent law to rewrite the left-hand side as a to the power of x times n. And this is equal to a to the power of z. And again, we have two exponential expressions with the same base, which means if they're equal to each other, the powers must be equal to each other. So we end up with x times n is equal to z. So therefore, we have now shown that log base a of b to the power of n is equal to n times log base a of b. And now we're going to take a look at simplifying a log expression here using various log laws. So we start with this messy looking expression here, and we want to simplify it, which means that we want to rewrite it as just one log. So the first thing we're going to do is we're going to write this is equal to log base 5 of x squared. So that's just moving the 2 up on top of x as the power. And then the next one, we can see that it has a different base. It has a base of 25, whereas the other two has just a log base of 5. So that tells us we want to go ahead and do our change of base here. So this is going to be plus log base 5 of x squared plus 1 over, and then that 1/2 just means that the 2 is on the bottom, and then we would have log base 5 of 25. And then our last one is going to be log base 5 of, and we're going, instead of writing that as square root of x, we'll write it as x to the power of 1/2. Okay, so now everything is in terms of log base 5. But before we do anything, we can actually evaluate log base 5 of 25, because that is just equal to 2. Okay, so now we're going to get log base 5 of x squared plus, so now our denominator here is going to be 4, which means it's really 1/4, so we can actually bring that up as a power. So this is x squared plus 1 to the power of 1/4. And then we have minus log base 5 of x to the power of 1/2. And now we're ready to combine these three log expressions into one. So we have log base 5 of, and then using our product and quotient rule is going to give us x squared times x squared plus 1 to the power of 1/4 divided by x to the power of 1/2. And then now the final step is we can simplify the x squared over x to the power of 1/2. So then our final answer is going to be log base 5 of x to the power of 3/2 times x squared plus 1 to the power of 1/4. Okay, so now let's go ahead and do a quick recap of everything that we went over. So we didn't just use the product and power rule here. We actually learned how to prove them using the definition of a log. We saw how logarithms and exponents are deeply connected and how that connection powers all of our simplification. And then finally, we went over how to simplify a complicated looking log expression using various log laws. And now it is your turn to give this a try. Can you use all the log laws at your disposal to simplify this expression here? Make sure to leave your answer in the comments below and let us know if you'd like to see more content on logs in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.